Take it now. Good afternoon, Saurabh. So, Saurabh sir, is I'm audible to you?
Yes, yes.
Yeah, you can take over the class. You can start the session for.
Yeah, just. Okay, hello everyone. Just a second. Okay. So, yeah, I think we're good to go. So topic today would be like very simple as we discussed yesterday. So what we'll be doing is, let's say, uh, it's gonna be about the similar thing that we are doing since last 3 days. But today we'll be using an completely open source model. So instead of now, see, last 3 days we have been using this OpenAI key, right? So which is like a paid one. So now we'll talk about an model which is like completely free of source, and which has the very perfect ability to talk with your, let's say, PDF. So what we'll be doing, we'll again build a simple rack system only, the way we built it yesterday, but in very, very simple format. Okay. Won't be writing very extensive codes, won't have like too many things to add. Step by step, I'll tell you how to do it. And every single thing today we'll do it on Google Colab. Okay. So I'll tell you that also, like what Google Colab is. And eventually we'll try to discuss how very very easily, like you will see the magic of it within, let's say, few lines of code. You are actually able to build the whole complete flexible system, right? You don't necessarily need to add any kind of extensive things onto that. It means what? Let's suppose now you have a certain amount of let's say, or let's say PDFs or data with you. Very easily you have that capability. Very easily you can just add everything in together. Let's see. Sorry, just a second. Okay. So very easily we'll be able to just get this particular thing, right? So what we'll be doing now, guys, before moving any further, right? Let's first of all try to understand a very simple architecture. So whatever yesterday I have told you, now behind the scene, how exactly this particular thing is working, right? Whatever architecture that we discussed here, this one, sorry, this one, or let's say one more that we discussed, right? So both of them are almost same, but this is just like a very mathematical representation of this architecture. Okay, now let's suppose when a particular text is coming, okay, then how exactly this text is processed and how we are getting the answer back. Okay, a very simple architecture is there. And as I discussed yesterday also, this was definitely one of the best evolutions that actually happened in this domain. Now, first of all, we'll be using something called as Llama Index and Mistral AI. Okay, both the things I'll be using today. So I'll tell you about both of them what it is. So as of Mistral AI is concerned, so I think I've already told you it's like an open source LLM. Okay, where you don't need to pay anything. Yes, they also have the paid versions also. It's not like they don't have, but their free versions are pretty good. You can definitely deal with any simple kind of RAG architectures. Okay, so what we'll be doing now, let's suppose we'll try to upload few PDFs, or let's say for simplicity, I've just kept one single PDF. So we'll be uploading that PDF. Okay, we'll write a certain amount of code, build some simple architecture, and we'll actually try to talk with that PDF. So it doesn't matter PDF is how long, 100 pages, 200 pages, 500 pages, doesn't matter. I have taken, again, for simplicity, I have taken only, I think, 20 or 30 pages are there. I think 15, 20, I'm not sure. So we'll be now uploading that, and whatever things you want to ask from the PDF, like you can easily talk with that. Maybe whatever topics are there, you can try to elaborate it. You can try to ask it. It's just like question answer system. Okay. So I actually plan to build an QA system only, but again, it could have added more complexity in the code. So I just thought let's try to keep it simple in the last day instead of just making it too difficult. Okay, so that was the first thing. So now, guys, understand here. This whole architecture that you see, right? This whole thing here, it's completely called as a RAG architecture, retrieval augmented generation. Okay, now let me tell you how exactly it works. Now, whenever you try to, let's say you have, let's suppose now I talked about PDF. Okay, so we have a PDF now. So what we'll be doing now, we'll try to, first of all, even if you have a PDF, what you need to do, let's say on ChatGPT, you might be uploading that particular PDF, right? So instead of that, let's say what we can do is instead of uploading that particular PDF anywhere, so now what we are doing, see, even if you upload what exactly ChatGPT is doing, definitely it will try to extract the data from that PDF, and it might be storing it somewhere, right? Without that, it's not possible, right? Let's say if I'm asking some question to my PDF, till the time it is not storing in his memory, it is not possible for him to answer about any kind of questions that we'll ask about PDFs. That's the simple part. Now imagine, let's suppose I have a data. So what I'll do, first of all, I I will try to insert this data into my LLM. Now, when I'm trying to insert the data, not like LLM, let's say I want to store this particular data now. So how would exactly we store it now? See, any process, this is called as, let's say, you can imagine this as a whole system, how exactly the system of this particular data works in the NLP pipeline or any generative AI pipeline. So what exactly happens is, whenever you try to pass this particular data, we try to divide this data into different chunks. You'll see text chunk 1, text chunk 2, text chunk 3, text chunk like that, like this. So now it doesn't matter. Let's say you are converting this into the 10 different chunks or 100 different chunks, right? Depends. Let's suppose your data is very, very huge. So usually we have something called as word tokenization and sentence tokenization. Okay, means what? It is compulsory that, see, you cannot pick up the whole PDF and directly throw it inside the model. It will not understand anything. You have to convert that either word by word. You have to split that particular words and then process that particular words one by one. Eventually, that word will be processed and it will be converted into the vector form. Another word will come, convert into the vector form. Another word will come, convert into vector form. But if the data is very, very huge, we use something called as sentence tokenizations. Means what? We try to split it on the sentences like this: 1, 2, 3, 4, like the sentences. We'll try to split it. Okay. So because of that, what happens, we just get that simple flexibility, right? We just get that flexibility. Now, let me just share something with you. Okay. Allow me a second. Yes. I need this one. Okay. Just allow me a second. Okay. So what I'll do, I'll just show you something around that so that it will be more clear for you to understand. Okay, when I say yes, yes, it is. Okay. Okay, now guys, is my screen visible? Okay, fine. Yeah, yeah. Yeah. That tab is visible. Allow me a second. Okay, see you. Wait, wait, wait. Sorry. Yes. Okay. Now seems fine. Yes. Now see here, guys. Now I'm just sharing this particular file with you. Let's say not this code. Okay. Just confirm if my screen is visible to everyone. Okay. Wonderful. Now see, guys. Now when I talk about any kind of pipeline, right? It's very normal. See how exactly we deal with it. Now let's suppose. Imagine. Let's suppose now you are just trying to clean the house for this particular, let's say, any kind of festival. So what we do usually, we just try to remove all the raw things that are there in the house. Whatever things are not clean, we try to clean it. And then again, we try to post it in a certain way, right? So whenever we try to process any kind of data, so these are the most basic things that we have to think about. Means what? Data cleaning, removing the unnecessary things from the data, right? Let's say we try to write many lot of things, like let's say GN or ASAP, or the shortcuts are there, right, on the in the chats, like you might have seen it. So we need to make sure that we are converting them into the very proper words, right? Because see, we need to pass this particular data to a certain algorithm, or let's say to a machine. So machines do not have the ability to understand such short forms and everything. So we have to pass that particular data in a very perfect format only. Okay. So because of that, what happens, let's say imagine now. That is the one part. Means what exactly what I'm trying to explain is converting, let's say, cleaning of the data is the most important thing that we have to do. Data cleaning. Because what happens, let's say what we do, let's suppose now you are trying to do a task like, let's say, sentiment analysis. Means you just want to tell how many, let's say, whether a given sentence is a positive sentiment or a negative sentiment. Let's say just like a reviews, right? Let's suppose movie reviews are there. So how exactly we do that? Based on reviews, we read it. So we just try to decide, okay, whether review is positive or negative. So now let's suppose now if I want to perform that particular task. So what is the simple thing now? Simple thing is to, let's say, one thing can be calculate total number of positive words, calculate total number of negative words. So let's suppose now, if the total number of positive words are more, then say that, okay, that particular sentence is a positive sentiment. And if the total number of words are negative more, then say that, okay, it's a negative sentiment. Very simple thing. Now, guys, imagine, let's suppose what we are trying to see, we are usually trying to talk about how many positive words are there and how many negative words are there. Now, second example, let's suppose now I am trying to do something called as document classification. Means what I have, let's suppose I have a bunch of text. Okay. Let's suppose I have 500 pages. And from the 500 pages, I've been told to, let's suppose now there are like multiple sections of that particular 500 pages. And I've been told, okay, do one thing, try to find all the topics which are hidden in this particular data. Means let's suppose whole this document is there. At least let us know, right? Means see, as a human being, it is not possible to read 500 pages and understand what kind of topics are there, right? So this particular generative AI or your RAG, or let's say this NLP, can do it very easily. So what we told him, whatever 500 topics, sorry, whatever 500 pages are there, from that, select and tell me what is this 500 pages talking about. Means what are the different topics which are talked into this particular whole data. So it can be, let's suppose, some documents can be talking about sports, some can be talking about, let's say, healthcare, some may be talking about finance, okay, some may be talking about politics. So we can have a mixture of, let's say, whole data. Now, guys, imagine, let's suppose, now when I talk about data cleaning, right? Now understand how important it is to do a data cleaning. Now, let's suppose we have the words like this, right? Let's say is, the, you, are, him, he. Means what? All these, the only words which are specifically used to, which only contribute to understand the meaning of a particular sentence, right? Apart from the meaning of the sentence, do they have any kind of significance? Definitely not. Let's suppose now tomorrow if I ask you, okay, what exactly is the topic hidden in the, let's say, this four sentences? Okay, what exactly topic they're talking about? So what do you think, like what kind of important things you will look into that particular sentence? maybe what are the important words may be used. Maybe let's suppose they're talking about, let's say, any kind of, let's say, political things they're talking about. Political words might be there. Some sports words might be there. So you try to look for such kind of specific words. And based on that, you try to decide, okay, what can be that, let's say, what exactly is the document that is talking about. Very simple and fair to understand. Now imagine, guys, let's suppose in such kind of document, let's say we have more words like this only: in, the, you, are, should, shouldn't. I mean, it's just like a stop words. We call them as a stop words. And we do not include such kind of stop words in our final data. Means, let's say I will get a certain data set. I'll show you now that example. After that data, when there is a need to pass this particular data to an algorithm, okay, at that particular time, this data has to be completely prepared. I cannot pass this complete raw data. I have to make that data in a certain format so that that algorithm can perform better on that particular data. That is a very simple logic. Okay. So removing such kind of stop words, let's say removing such kind of unnecessarily, HTML tags are there, because if we try to scrape the data also. So while scraping the data, we get all these HTML tags and everything. So there are like multiple things that are actually available in the data. So we need to make sure that we are cleaning this complete data in a very, very proper format. Okay, now imagine here. Let's suppose now what I did here. Let's say I have taken one simple data here. You can see that it's like almost 50,000 movie reviews are there. Okay, so there's a movie review, and corresponding to that particular movie review, we have a sentiment of the data. Let's say it can be positive sentiment, negative sentiment. It can be anything. Okay, so now imagine here. So you can check the let's say shape is 50,000. Okay. So when now see guys, now I'm talking about pre-processing on the text. Right. Means what? It is actually important. This is like the first step that we do into any kind of NLP problem. Okay. So there are like multiple. Okay. I am not planning to talk about each and every single pre-processing thing that happens. But the only thing I wanted to tell you is that how important it is to clean the particular data. Okay, because see, whatever I'll be showing you now, okay, whatever things we'll be doing now, when I talk about chunking, right, sentence tokenization, that is also there over here. So with respect to that only, I wanted to show you how exactly that works. Usually now there are multiple steps that we perform in this pre-processing, right? So the most important things is something called as lower casing. So now why lower casing is important? Because see, Python is a case sensitive language. Now if you write, okay, H capital, hello, how are you? And hello, something like this. Means now when I'm trying to calculate the frequency of the words, so this ONE or is, let's say here written is there ONE. So now it's a capital word. Now, sometimes in this particular whole sentence, if there is ONE written somewhere else, so these two will be calculated as a two different frequencies. Because Python is a case sensitive language. We cannot take this one and this one separately, right? Basically, they are the same only. Only this is a capital and this is a small. So therefore, what we do is, we try to reduce this complete thing into lower format. You can see like everything into a lower format. Now here you will see that, let's say there are like HTML tags like this, right? So there are multiple things. Let's suppose if I now show it's a DF ka. So I'll show you the first of itself. Or it's a second. See here. I will see that here, guys. There are multiple, such kind of HTML tags that are present. See here, all these HTML tags here. So means what, guys? See. Now you might ask, why do we need to clean it? It's very simple, right? Why do you want to keep something that is completely unnecessary and that is of the no use? Because imagine, guys, when I'm trying to split this data, okay, every single data takes some kind of memory to store. Now, while processing this particular data, every time whatever processing I'm doing on this particular data, eventually that will be happening on this particular also. So when you know that this is of the no use, whether you do any kind of pre-processing on it or whether you store it, that's just like a waste of your own resources that you definitely don't want. So we always try to keep only those amount of words, or I would say data, that is actually important with respect to that use case. Let's suppose whatever kind of use case I'm trying to solve. So with respect to that use case, XYZ things are important. So I will only try to keep those things. Apart from that, I will not keep anything. It's just a simple analogy of that. Okay. So let's not go into these details. Now here you will see that I wanted to tell you about this. Yeah, sentence tokenization. See here, guys. Yeah, see here. Here, word tokenizer, sentence tokenizer. Now, if you just talk about this one, no, see here. This is how exactly. Let's suppose this is my one sentence. Now, like this, every single word will be split into the different text. So when the tokenization is happening at that particular time, every single word will be passing one by one. Okay, every single word will be passing one by one. Now, if you just look at here, see here. Now, let's say this is my text that I have. Okay, now in the NLTK, so this is like a core Python library, like a natural language library. So in here, now see, now I'm talking about very statistical things. Let's say if you want to build a model from scratch, let's say core NLP. Now this is a core NLP. It's not a generative AI. Okay. So in the generative AI today, we'll see like we have something called as the recursive text splitters. So those are already given by Hugging Face embeddings or OpenAI or let's say your Chat GPT. Already inbuilt is there, but still you have to use it. So you should just have that context. Ki, okay, what exactly we are doing. So there you will see something like that. So here we had something called as word tokenize or sentence tokenize. Okay. So if the data is, let's say, very, very huge, let's say 1 million rows are there. So in such kind of things, you can definitely use the sentence tokenization because it is not possible to process one word for such a huge amount of data, right? It can be time consuming thing. So therefore, what we do, we try to use a word tokenization or a sentence tokenization. So in this, what will happen is, let's say now suppose if I'm saying, okay, I am going to visit Delhi. So if I now do word tokenize, okay, I'll need an okay time. Okay, wait. Okay, now see guys. We will see that this is how exactly the data will be processed. See, I am going to visit Delhi and this one. So understand what I told you. Even this explanatory mark is now getting separated. Understand here. So therefore, we have to think about removing every single thing like this we have. Because see, this explanatory mark is not going to tell me, okay, whether the topic is talking about, let's say, sport, politics or let's say sports. So that is just like what? It is just used to complete the sentence, just to get the meaning of that particular sentence. But while processing the text, we don't look at that particular thing. Okay. We try to remove every single thing, every word that is not important with respect to that use case. Okay. So like this, I will be removed, am will be removed, to will be removed. Okay. So all these things will be removed. So yeah, visit is important. Delhi is important. Okay. It's talking about there is a meaning to that particular thing. Okay. So therefore, we always try to keep the words which are important. Now see here, sentence tokenization, what I did now, sentence by sentence, it will tokenize here. First sentence is now one tokenization, second is second, and third is like this. Okay. So there are two types of tokenizations that happen. In this combined application that we'll be building, there we'll be doing a text splitting only. So whatever this graph that I shown you, right now the image. So in that you might have seen, okay, word one, word two, like splitting of the data. So the splitting of the data is happening like this only, whatever we are doing over here. Okay, so that is how exactly we try to deal with this particular thing. Now, when I talk about, let's say, stopwords, right? So what do you mean by stopwords? So basically, these are the, okay, let me see if I have this here. No, yeah, I think it's there. Yeah, see, removing stopwords. So what we do now, and one more thing, guys, implementing these things are very, very simple. Okay, I mean, it's not difficult. Imagine, let's suppose you're writing 3 lines, let's say 3 words from nltk.corpus, import the stopwords, and that's it. Then you are downloading all the stopwords. Okay, let's suppose I'll do this. I'm downloading all the stopwords, and you just need to provide the language over here. So you have the stopwords in different languages: Spanish, English, Hindi, Japanese, or whatever language you take, you have. But usually we deal with English, so we'll take the English stopwords. Now, if I run it, see here, guys. Now these are all the stopwords that we have. See here, a, about, above, after, a, against, all, and between, d, didn't. So all these kind of words are the stopwords. Means what? These are the words which are specifically used to understand, or let's say generate the meaning of that particular sentence. Okay. So it will just try to get the meaning of that particular thing. So we try to remove these kind of things, because now imagine, let's suppose now I want to understand which particular topic a certain document is talking about. Now let's suppose then I thought, okay, let's try to get the frequency of each and every word. Right. That can be one way, right? Let's say if I get a frequency of every single word to understand which topic is there. So definitely I can get that particular frequency. But now imagine if I keep these kind of words. So definitely the is there, a is there, am is there. So all these words will definitely be coming much more number of times than the actual meaningful words, right? So there will be no meaning of, let's say, keeping all these kind of words. So therefore, we always try to remove all such kind of words. We don't keep them. So like this, now what we did, we have splitted all the words. And now see, okay, hello, my name is this. See, hello and name. Only things are remaining. My and is already removed. So like this, now from the whole data, we can remove this complete things in together. Okay. So that was just a simple example to tell you how exactly this tokenization actually works. So now when I did over here, right, let's say here, text chunk 1, see here, this one, text chunk 2, text chunk 3, text chunk 10, like this. Means whatever amount of data is there, we will try to split that data like this. Now, once the data is splitted, then we try to convert this into the embedding forms. As I told you, embedding means what, guys? Converting any kind of textual data into the vector form or numeric form is called an embedding form. Because why I told you? Because machines cannot understand the text data directly. So we have to convert that into the embedding form, or we can say vector form, numeric form. Okay, now see, now here you have already OpenAI embeddings are there. Means now you don't even need to create the embeddings also. Like when you talk about today's world, now you don't need to create the embeddings. Okay, now but let's suppose now if I talk about just now I showed you the classical example of NLP. Now let's suppose now if 5 years back if I'm building the same project, so at that particular time I have to think about 10 different algorithms. Let's say maybe there are algorithms like okay, let's say word to wake, okay, glove, okay, then bag of words, or let's say one hot encoding, okay, TF-IDF. So these are all the different types of embedding techniques we have. Embedding techniques means what? Converting your textual data into numeric form. So this is a whole process, right? We'll get the data. Okay, we got the data, that's fine. After that, we need to clean that data. After cleaning that data, we need to convert that into the vector form. After converting into the vector form, then we pass it to the algorithm, and then algorithm will give the predictions to us. So that's like a whole process. Now in here, let's suppose if I don't have an OpenAI embeddings, or let's say if I don't have a ChatGPT type of model. So what we have to do now? Now we have to think from every single perspective. Okay, what kind of data is there? Then for that particular data, which type of algorithm of all of this will be very suitable, right? Which will be very suitable. Now again, this is like completely trial and error thing. Okay, so it's like completely trial and error. Okay, you either try this and check the results, you try this and check the results, try this and check the results. Like this, try it and check the results and see which one is coming better. Okay, but after a certain period of time, you just understand that okay, this kind of data is there, you already work with that. So you know, okay, let's suppose for a certain type of data, TF-IDF will work better. So now in here, see here, whatever things are happening, right? Let's say embeddings over here. So these are the embeddings that we have. So in classical NLP, natural language processing, we try to convert these embeddings like in this particular format using algorithms. Now here, you will only write one single line of code. I'll show you now. Okay, we'll see that. In one single line of code, every single thing, all the text that you have is directly converted into the embedding forms. Now, guys, once the embeddings are done, you will see that every single thing is taken together over here. And here we have built the semantic index. Now, semantic index means what, guys? As I told you yesterday, means just simply storing the complete data that we have into the one single place. It's like a storage. Okay. And here, as soon as it's done, now we'll try to pass that particular into the knowledge base, or let's say vector store that we have. Like, see, now we have built this particular data. Okay, I have got all the numeric values in together, but definitely I need to store that data somewhere, right? So for that storing, we need a vector storages. Okay, now for the vector storages, we have FIs in today's world. Okay, FIs is there. Then we talk about Pinecone. So there are multiple, let's say, open source databases are there. You can directly store it there. Now what's happening, guys? Now see, now till here, what's happening now? Whatever data that we had till now, we have taken that data and we have stored that particular data in a desired format, right? We got the data. Let's suppose we have one simple PDF. Let's say I want to talk with my PDF. So I upload my PDF. As soon as PDF is uploaded, automatically it is converted into the chunks like this, chunks like this, chunk like this, chunks like this. Finally, I am now converted into the embeddings. That is also happening automatically in today's world, right? But if we talk about classical NLP, then I need to take the data. I need to think about, okay, how exactly I'm going to split this data. Then I need to find out the different splitters. Okay, what kind of splitters I can use. Then I need to think about texting and embedding I already told you about. Okay, and here we are showing the knowledge base. Now what's happening, guys? Now what's happening? Let's say there is a user. Let's say this is you. This is a user. So what this user is doing now, let's suppose this user asks a question. Hello, what is OpenAI? Let's say this particular user asks the questions. Now, same procedure. Let's suppose even if you're asking the question to a chat GPT, the same procedure is happening. You're asking a question, that question will be converted into the query embeddings. Query embeddings. Because see, what I told you guys, it is not possible to pass the direct text to any kind of model. You have to convert that into the numeric form only. So here we are creating the embeddings out of it. Embeddings means what? These ones. Let's say converting text into numeric form. Example. And after that, we are trying to find the semantic search of this particular data. Means what? Whatever this query has asked, whatever you have asked. So we'll try to search this particular query inside this knowledge base. We'll see, okay, whatever similar context, let's suppose now this is the format I got. Let's suppose 0.3, 0.3, 0.3. Let's say sentence is converted into, let's say these embeddings, 0.3, 0.3, 0.3. Because what we do, what I told you, text splitting, right? And just now I shown you how exactly text splitting works. One text separate inverted comma, another text separate inverted comma, third text another separate inverted comma. So every single word is into the separate inverted comma. So for every single word, we'll have the separate embedding value like this 0.3, 0.3, 0.3. Let's say this combination of this whole three is one, let's say one sentence. It's like that. Okay. Now what I'm trying to do, I am just trying to find whether is there any kind of similar kind of context. We'll see guys like this here, right? You can see all this data is stored into this kind of format only. See here, like this we have, and see all this particular format is like this. So we'll try to see, is there any kind of similar kind of, let's say, thing that is available in this particular whole document? Okay, now it will search. And it found out that, okay, yeah, there are some kind of documents which are talking about OpenAI. Now it will, let's suppose now PDF is 100 pages. And from that, let's say this question, we got to know that, okay, there are almost, let's say 3 pages which are talking about, let's say OpenAI. So now what we'll do, we will try to take these 3 questions or 3 pages from there where it is talking about OpenAI. We will take this particular user query over here. And in general, we will try to pass this complete thing to an LLM. Let's say OpenAI or any kind of model. Okay. So it is just like that. Now imagine this whole system as how, let's suppose, let's say this is the student. This is the student, right? And now student, let's say you are a teacher. Okay. So you have this particular PDF of 500 pages, and let's say you have the complete idea about this page, like where exactly everything is stored, what kind of, like in what section, let's say maybe not exact PDF number, page number, but yeah, between this 1 to 5 page number, I will, let's say I can find about XYZ thing. So that much idea. So this student came and he said, okay, hello ma'am, hello sir, I'm not able to understand this particular topic where it is present here, and I need more understanding about it. So now what the student is doing now, he's coming to you like this. He's coming to you here. Now you are already here. You are already talking with him. Now what you are doing? Okay, he said, okay, sir, ma'am, I need to understand about OpenAI. Now you know that in the page number 300, 301, and 302, we are talking about OpenAI. So now what we'll do? You will only take these 3 particular sentence or PDFs, pages, and you will only talk about these particular pages only. Very normal. You won't be reading the whole PDF again, right? Because you already have the idea. You already did the search. Whatever this search this whole year it's happening, that search you already did that. So now you have the idea, okay, it's present over here. Now what will do? Okay, you will say, okay, come here, sit, and now I'll try to explain you what exactly it is. Now this LLM is just like your own brain. So from your own understanding, now you're trying to explain that concept again. So now what we are doing now here, we are passing everything to an LLM. So LLM has that ability to think in a very unique way, very proper way. So whatever questions you will ask with respect to this particular PDF, automatically LLM will try to generate the best possible responses for you. Okay, so this is the whole system, and this is how exactly this complete architecture works. Right, guys? So before moving into the implementation part, is everyone clear with this one? Like got a simple idea how these things are working? Yeah, I think this was like in most simplest terms that we have gone, right? Yes, please let me know. Okay, seems like no one's active here. Okay, anyways, so I hope this is pretty clear to everyone. Now, what we'll do, let's try to understand about what exactly things we'll be implementing today. Okay, so specifically now, we'll be talking about what is Llama Index, right? So, and second thing, we'll be talking about what exactly is a Mistral AI. So these are the 2 things that we'll use to build the model that we are building today. Whatever system we're going to build today, so that is the thing that we'll be using today. Now, imagine, guys. Now, let's suppose first of all, what exactly this Llama Index is. Okay. Now, imagine. Let's suppose a very simple example. Now, imagine. Let's suppose you are trying to build an LLM application. Okay, let's say now whatever things that we are seeing, let's say you are trying to build an LLM. Okay, so imagine this Llama Index is like a framework Okay, that helps you create LLM applications. That helps you create LLM applications very seamlessly. Means what? Let's say now we talked about the data, right? So that data will come. Then where exactly we should store that data, right? So then Llama Index says, okay, don't worry. I have that particular storage. Come and store it inside me. I can handle that. Okay. Means what? It is just like an orchestration. Whatever whole system you are building, it is just trying to orchestrate everything. It is just trying to connect. It is just trying to connect all the dots together. Because that is the most important thing, right? Let's say like this only you have something called as you will learn LangChain. Now this is like more famous. Okay, it's like on a very high scale. But Llama Index is like bit simple. So therefore I thought let's start with this one. So Llama Index is and LangChain basically both are the same things. They are just used. They are just being used to integrate all these different tools together. Okay, so it just like see, it just acts like a connector. Connector. Okay, now see, it just acts like connector between, let's say, between your data. Let's say now here our data is what? Let's say PDF. Here we have taken today. We'll be taking PDF as a data. Let's say now it will act like a connector between the PDF that you have, or let's say any kind of thing like PDF, doc, or textual source, whatever it is. Okay. And the LLMs. And the LLMs. So it will help you to integrate, organize, and retrieve the data or information very easily. Very easily. Okay, so it's just like a bridge. Okay, it's just like a bridge that connects, we can say, the data to a some kind of source resource. That's the simple thing. Okay, that is what exactly it is. Now say you upload and certain thing to an chat GPT, so then you're asking questions about it. Now let's suppose now if you want to integrate your own custom data, okay, now you want that data to be connected to the LLM, right? There has to be some kind of way, because see, okay, understood. Imagine, let's suppose now I'm again into this particular case. Let's say I'm here. Okay. Now let's suppose now I got my text. Okay, it's fine. I got this whole data. I even got the embedding, that is also fine. But there has to be something, right, which will help me connect this particular embedding with my actual LLM. This is what exactly the work of this particular, sorry, where it is. So this is what exactly the work of your Llama Index. Okay. So it is just like what you can say. It is just like an orchestration of building an LLM orchestration. Okay, so Llama index or orchestrates building LLMs. Okay, now after, let's say it is also fine. Now you will also heard about something called as LangChain. Definitely worth exploring. This was also a great evaluation. And now in today's world of, let's say, agents, right, where AI agents are created. Now the whole orchestration is happening with LangChain also, but there is something called as LangGraph. Okay, now it is managing all this particular workflow. Let's suppose now there are two different agents. Let's say I created three different agents in my system. But how exactly this agent will try to connect with him? How he will connect with him? How exactly he'll connect with him? So this connection between all of them, no? So this is called as orchestration between these different agents. So that is handled by LangGraph, or let's say LangChain, or simple terms in Llama Index. Okay, so Llama Index helps you bridge the data from various resources. It will try to get the data. It can be from files, it can be from websites, anywhere, and it will try to see. It can try to load that data and process that data very effectively. Very effectively. So it can do multiple things. First of all, it's like it will do a data loading. You will see all the components. Don't worry. Okay, data loading. So means Llama Index will try to load your data from wherever you are getting the data. It will load the data. Let's say it might get the data from, let's say, PDFs, or maybe let's suppose some kind of various resources, let's say APIs or scraping or anything, right? Or let's say clients data, anything. After that, it is indexing that particular data. Indexing that data. Now see, when I say indexing, means what? Whatever we have seen here, see here. After embedding, here we are creating the index of the that particular thing, right? So every single embedding is to be considered as an index. We need to give some kind of name to it. Okay, yeah, this particular, whatever text is there. So the meaning of this particular text is XYZ, and it is based into this particular position. The index of that particular word is this particular thing. Let's say index of Saurabh is 1, index of XYZ is 2, index of third person is 3, just like roll number. It is just like a roll number. Okay. So this roll number thing is handled by this particular thing that is called as indexing. Okay. So once the data is loaded, it needs to be indexed. So see, it's just simple, right? Let's suppose now I cannot write, let's say you have the bunch of students. So I cannot write the name of student. Okay, here one student, let's say A, B, C, D. Let's say I'm writing like these student names. Now, definitely I'm writing like this. So definitely that is not something worth, right? I mean, not very manageable thing. So how will I write? Okay, first number pe S is there, second number pe A is there, third number pe D is there, fourth number pe XYZ is there. So now this is a very organized way. So whenever I'm converting this text into a number form, because imagine we need to preserve the meaning, right? Let's suppose now I'm splitting the text. I splitted the text here. Here, the text is chunk is splitted. Now, when this chunk is splitted, let's suppose now the chunk in name is, let's say, hello. Let's say hello was that particular word. Now this hello is converted into, let's say, embedding the value, let's say 0.7. So now when I'm saying this 0.7, I need to preserve the value of this particular 0.7 as a hello, right? So therefore, I need to index this particular thing. Means it has to be indexed at a particular thing, at a particular place. So this llama index organizes the data in such a way that all the models, means very easily you can find it. Okay, if you just give the word itself, immediately it will try to find out, okay, yeah, it is talking about, let's say, this particular index. So this complete indexing is handled by llama index. Okay, so it does all the things. Means it will, from breaking the data into smaller chunks, converting that into the embeddings, and again storing that data into the vector databases. Let's say here we have stored the data, right? So this complete procedure, let's suppose now this complete procedure, this one is completely handled by llama index, creating the indexes, then finally storing into the knowledge base. So knowledge base can be anything. Files, vector, there are multiple databases that you can store the data into. As a company, which databases you use? See, as a company, usually now if I talk about us, right? So usually we use something called as Elasticsearch. Okay. So Elasticsearch is like very effective database where, very easily you can manage the complete workflows. Okay. All the data can be managed. But usually now in the today's world, you have better databases. Like let's suppose you talk about FIS. Okay. Then you talk about, let's say, Pinecone. Okay, so these are the kind of database. Multiple, there are multiple, but these are the few ones, right? And very easily you can connect them. Okay, I mean, it's just like creating an account on Facebook. It's just that easy. It just names are very fancy, but using them is very, very simple. Just store it and you can very easily create all the data. Now, I told you about, let's say, I know, let's say loading the data, let's say data loading. I told about data indexing. And even it also does something called as query the data. Okay, asking the questions that a user has asked. Now imagine, let's suppose when I say querying data means what? Whenever user is asking a question, right? So I need to search that particular question into my database, right? Let's suppose if I want to have answer, okay, hello, so tell me what is the meaning of generative AI. So let's suppose now I have this complete data that is stored over here. See, this one, whole data is stored over here. Now from that particular database where I have stored, see this here. So from this database, I need to search, right, where exactly this particular talking about generative AI. Then only I can give an answer to my user. So to query this particular thing, or let's say to understand or to find where exactly that particular thing is hidden in that whole database, that work is also done by llama index only. That is also done by something called as llama index. In simple terms, guys, what is this llama index? In simple terms, guys, llama index is a process where we try to build this whole system. Means orchestration. Every single thing is connected using llama index. Okay. So every single thing is handled, means what? Complete orchestration. Orchestration. Everything. Okay. So from handling the data to converting the data into the index format, then storing that into the database, and then finally sending this whole database to the LLM, searching where exactly whatever user has asked, searching that particular query, relevant query in the database, every single thing acts is handled by LMS. Sorry, this particular llama index. So in very, very simple terms, what you can act, it basically acts like a middleware. It's just like a middleware that organizes everything. It organizes every single thing. It stores, it provides, it gives the answer, it gives every single thing. Okay. So now see, today we'll be using llama index. So imagine, let's suppose we have just taken a huge amount of text in one place. So now from this particular text, taking out the data, whatever data, that doesn't matter, one page, two page, three page, 1000 pages, 1000 such document, doesn't matter. It can handle, it has that ability, it can handle it. So taking out that data, storing that data in a very organized format, converting that data into embedding format, that is numeric format, and finally using that particular queries to effectively give the answers. Every single thing, the middleware of every single process of every process is this one, this llama index. And this same thing is done by LangChain also. It's just like bit high scale and same like a LangGraph also. But today we'll learn about LangChain, llama index. Okay. So now that is it, guys. Now let's suppose if I now show you. So this is our official documentation, right? And never forget to read the official documentations. As I told you, you will get like the best answers there only. So it is an open source data orchestration framework for building the large language applications, especially those leverage the RAG architectures. Okay, so you can definitely go through their official documentation, and here you will get the complete details about how exactly this particular thing works. And all the things are there. Just go to some blogs. You'll find it like, what are the latest improvements into that, how to build the simple things. Every single thing is written over there. Okay. So definitely, if now see, you can literally orchestrate anything. Either you can create text to image, text to image, text to text, text to video, text to audio. Anything is possible. Right. So now can be like this can act like a very, very good, tool for you. Okay. So just like this particular thing is there are like multiple like this we have. Okay. So there are multiple like this we have. So I hope now it makes sense. And now see guys, now the second thing that we have is, Mistral AI. Now see, we use the open AI, like we use the ChatGPT, right? So exactly similar, we have Mistral AI. I'll tell you what it is, right? Mistral AI. See, now this Mistral AI, it's just like a ChatGPT. Okay, it's just like a simple ChatGPT. The way you have been using ChatGPT, you can use this particular Mistral AI. Now, to load, now see, yesterday what we did now, we had an API key, right? We took that particular API key, we stored it in our system, and then we were able to interact with the LLM, or let's say ChatGPT. Now, similarly, you can do the exact same thing. Just click on try API keys. Okay, if you go here, simple process, just sign in and get the API key. Okay, now imagine you can either get this particular, no, let's say use this particular model, or let's say this particular LLM using API key, or you can directly use this particular model using something called as Hugging Face APIs. Okay, Hugging Face APIs. Now, first of all, these Hugging Face APIs are what on the very first day I told you, right? All the open source models, whatever models are there which are open source, which are free to use, every single model you will get it here. Every single model you will get it here. Okay, there is nothing like you can't get it here. Every single thing you will get it here. But now for this, now what you need to do, you need to create the API key of this particular Hugging Face. How will you do it? Very simple. Let's suppose simply log in. Okay, simply log in into your account. Now from logging into account, just go to your settings here. Just like I'll directly provide the link to you. Okay, you can directly go to a link there. So go here, go to the settings. Let's suppose your own profile, or yeah, settings here. If you come to the settings, you will see access tokens over here. And simply now see, create an access token here. Give the name, let's suppose now Mr. AI something, and get the read mode now. Because now see, fine grain will not work. Just do what I say. It's just like read mode. Means what? Now here you have the multiple permissions. So you are giving a permission. What you are saying, okay, whatever API key that you will be using. So with that, with the help of that particular API key, you can access all the different open source models which are present in this particular Hugging Face. Whatever models are present, every single thing is present over here. So if you write a write, you will get a write API. If you get read API and fine grained API. So usually a fine grained is more, which is very much restricted. Means very simple things you can't use, but after certain limit, it might not work. So read, just keep read and simply create the token over. Now, as soon as you will hit create a token, you will see that you will get an API key like this over here. Now see, it is only one time visible. Okay, simply copy this API key, and now we'll see how exactly and where to paste this particular API key. Okay, so I hope guys, this simple thing is clear, like how you should basically get this API key, right? Now from here, I need to specifically find, okay, which particular Mistral model I need to use. Now, if I click on this Mistral AI, right? See here, guys. Now, Mistral AI provides me with 26 different models. Mistral AI provides me with 26 different models. Now, it depends what kind of thing you are trying to do. If you are trying to do only textual thing, maybe you can use something else. If you want to do some kind of image thing, you can use something else. Depending on the kind of thing or kind of solution that you are trying to get, you can use that particular thing. Okay, so this Mistral Nemo instructor, 2407, Mistral large instruct, 2.07, 0.1, 0.3. So all these different names are there. It's just like a names of one single model. Just like one family is there, and these are all the names of brothers, different brother names. Okay, surname is same, Mistral. Okay, these are the names of different family members. Okay, so like this now, from here now we thought here for the text generation, I thought as we have used it, so I thought this particular model called as Mistral 7B Instruct V 0.31 or 0.1. These two can be perfect to use for my particular application. Or I can use this one. I think we have used this one only. Mistral Instruct 7. If I click it now, I don't need to anything. You will see interface like this. Simply click on agree and access the repository. Agree, simply click on here, agree and access the repository. Now, guys, you can use that API key. You can just take the name of this particular model and very easily you can create any kind of application. Okay, now let's try to build this application. Okay, so I hope now the simple things are clear. Like let's say how to now let's say get the API key from Hugging Face or everything is clear. Okay, so I think we have used this particular model. Yeah, we have used instructor 0.1. Now, the only thing, or let's say the only way, I'm telling you to use this, like I wanted to tell you the power of this particular LLMs, right? Means this is like a very simple model. It is not like, yes, but it is a level is same, not exactly the chat GPT, but it's almost same only. So from here, you will understand that like it also has the ability to give the answers very perfectly. There is like nothing wrong using open source models. So therefore, I told you, right, in maximum places, like whenever we have to deal with a very large scale applications, right, we always think from the perspective of open source models. सबसे पहले the initial step will be taking it, okay, are there open source models? Are there any open source models doing this task effectively? So first we'll be searching, I'll be searching this particular thing. And then I will think about, okay, whether I have to go for the paid ones or not. Because on a large scale, guys, handling these paid versions are very difficult. Yeah, on a small scale, on a personal level, it's totally fine. But when you talk about it's an enterprise level, where you will have at least 1 million users, in such kind of scenarios, it can be very problematic. Okay, so like this. Now imagine, let's suppose now this is done. Let's say, let's get back to my coding part now. See here. Mm, my coding better. Yeah, so I'll be writing everything from scratch, so do not worry. Yes. So guys, okay. First of all, till here, any issues to anyone, guys? Till here, all good. Everything is there. Wonderful. Now see here, guys. Now very clearly I have mentioned talk with your PDF using Llama Index and Mistral AI. Okay, that's a simple topic. Now this particular thing is called as Google Colab Notebook. So first of all, guys, how many of you know about this Google Colab Notebook? Like, has anyone worked with it or has anyone seen any kind of applications around it? Anyone? Yes, guys. Yes, sir. Worked on it multiple times. Google Colab, I know. For algorithm information. Great. Okay, seems like many of you already have an idea about it. So basically, guys, this, let's say, understand. Yes, yes. Okay. See, basically now, even even when we work, okay. So usually, while training this classical deep learning models, okay, classical deep learning models. So we used to use this simple, collab notebooks, because what happens, see, it's completely free of source. They provide up to 10 GB of the, let's say you have the, GPU that you have, you know, free GPU is there. So it's always good to use the free GPUs. So you have a better GPU, it works pretty good. I mean, let's suppose now, not that great, okay, not that effective, but more than this, you might have heard about something called as Kaggle notebooks. So these are like, let's say pretty fast. I mean, usually, we used to use these Kaggle notebooks for building a very, training a good models, okay? Because this notebooks actually provides you with, here you can see that you can actually have the very good accelerator. So when you have the accelerators here, somewhere you will have, see here, accelerator, okay? So you can have T4 into double two, it's like into two. So means, let's suppose if one model was taking us, let's say 1 hour to train, so it will take only half an hour, or let's say 20 minutes to run. Okay, Baki interface is just changing. Baki everything is exactly same. There is no difference between them. So here you will see that I have only T4, right? So here it's like T4 into 2. So that one is there. So this Google notebook is just like an open source, we can say a model. Okay, that is given by Google, where what it says, okay, you don't need to explicitly save anything on your local system. What you can do is very easily you can just come and use particular notebook, and you can write your codes over here. Okay. So now to build this, what we did now, see, first of all, as I told you, we'll require some kind of certain things over here. Now, the first thing that I'll require is, I need to get all the, different required things into my Colab environment. I need to get every single thing into my Colab environment. Okay, guys, first of all, let me check whether okay, my, this open thing is visible, right? Talk with your PDF Llama index using this one is visible, right, everyone? Yes, okay. Now, yeah, I think makes sense now. Let's suppose now, see, first of all, guys, now let's start and build some simple things over here. So first thing that we need to think about and do is install the required things. So first of all, what I'll need, Llama index LLM Hugging Face. Okay, I'll need these things. So I'll just install it. So it's like pip, like this we write. Now in the simple thing, okay, in simple VS Code, what I shown you, in the VS Code, let's suppose, I'll just share one tab. No, what's the big deal? Okay, let's suppose now if I want to do, so here now I have to write, let's say pip install XYZ thing. Pip install, let's say anything. Okay, but at the same time now, when you're talking about, let's say, okay, sorry. Now let's suppose when you're talking about this, okay, I can't see it. Wait. Yeah. So now when you talk about this one, right, let's say your open source things. So in there now you have to use this percent pip like this, or either you can use an explanatory mark also like this and pip. Both the things are fine. Okay. So it just, gives you, so that is just like an, you can say, indicator, or you can say, let's say that is what is the starting point of it in simple terms. Okay. So here you'll see that now I see it's installing, right? You'll see that it's downloading different things over here. Okay. Uh, yeah, I think seems like it has downloaded. Okay. So now guys, okay, now that is done. Now one thing is done. Now what I need to do, I need to go to my next part. Okay, still it is downloading. Wait. So it takes time, right? Now see, because these models are very, very huge. Okay. That also I'll tell you how it is handling this complete memory management and all. That also is. Okay. Now that is done. Now the next thing that we need to take is, let's say that this is done. Now I need a Llama index. As I told you, right? We are building a Llama index. So definitely I need a Llama index here. So pip install Llama index over here. Here. So it's like collecting, and let's say it's downloading over here. Okay, successfully installed. Can you see this now? Successfully installed. Now, let me explain you one by one what exactly we are doing. Now, see, from Llama index, from Llama index dot core. Okay, now see, a very one simple line I'm just writing. Okay, import. See, guys, only I'm writing is what? One single line. Simply import vector store index. Okay, I'll need vector store index. Similarly, I'll also need simple directory reader. And guys, that's it. Only thing you need to write is this particular line. And automatically you just, okay, take this vector over here. You will pass the whole whatever document PDF you have inside this, and automatically whatever the whole process I explained you, right? This one, this complete process over here. Now look at this process. There is my this one. Yeah. Now look at this one. Whatever thing I have shared you over here, like splitting the text, converting into embeddings, every single thing is done within that one single line. Means here it is directly storing into this vector store. Here, vector store you can see here, this vector store. Okay. So means what, guys? As I told you, right? It's very simple and easy to write. Writing the codes is not difficult. So what do you do now? From llama index.core, import vector store index, simple directory here. Now here also you might say, okay, then do I need to by heart these all the names? No. Simply say, okay, let's suppose now I want to store my database inside the llama index. How to do it? Simple as Google, simple as GPT. It will give the exact same answer. Second thing, now llama index.llms, import Hugging Face LLM. So I told you about that Hugging Face, right? So in that we are using Mistral AI. So Mistral AI is the LLM that we are using for this particular project, right? We are not using OpenAI, right? We are using Hugging Face API. Sorry, that is Mistral AI. So therefore now, but from where to import it? So we have to import it from the Hugging Face, right? So therefore we have imported this. And see here, guys, your Phenomics packages. Which package is not there? Wait. Okay, let me just see. Okay, okay. I think I'll need to do dot Hugging Face. Sorry. Yeah, okay. I think it should work now. Okay. Yeah, fine. Okay. So now this is how exactly now we have loaded it. So now what happened? See, guys, the model is loading. Eventually it will just load. Now see, fine. Now I have this Hugging Face in my environment. Now imagine this is your virtual environment. Means what? This collab is a virtual environment. As soon as this is disconnected, you have to run this again. Now it is not stored into this particular thing. So as the same thing I told you in the VS Code, once you install the dependency, it will remain forever. Now it automatically it will not be deleted as long as you will not delete it manually, it will not be deleted. But here it's not a case. It's open source. As soon as your runtime is disconnected, okay, you see runtime. As soon as it's disconnected, no, see restart or interrupt. After certain amount of time, if you don't do anything in this, no, automatically it will restart. Right. So if you don't do this now, again you have to run this complete things. Okay, so that's just like one thing that we have to take care. Okay, now guys, that is happening. Now what I'll do, first of all, let me just upload one PDF. So recently I've just taken one PDF from somewhere. Uh, it just talks about had this PDF stored where, but wait, let me just see. Okay, let me just check where the PDF is. Sorry. Okay, just a sec, guys. Oh, I think I'll have it here only. Wait, it's not there. Yeah, GenAI principles is there. So it is stored in the downloads. Not PDF. Okay, fine. Got it. So what I'll do now, see, first of all, what I need to do now, guys, I need to first of all get this particular data and store it inside my, uh, yeah, store it inside my application. So you can see all this screen visible to everyone. Okay. What happened? How it got disconnected? Oh my God. See, reconnect.
It is visible, sir.
Oh, I'm sorry. Why can't I see them? It's visible only, right?
Yeah, it is visible.
Okay, let me just, I think something just got off wrong. Wait, just a second. Yeah. Yeah. Yes. Oh, sorry. It's got a bit confused. Okay. Now, let me again share it. Oh, okay. So now you'll see that. So what I'll do first of all, see guys, now that is done. So what I'll do now, let's try to create one simple folder here, right? Let's try to store that complete data into that particular folder. So what we'll do, let's try to create one folder called as, let's say, data only. That is done. What I'll do, let's try to take, wait. So there is a simple thing called as make directory. So how exactly we do that? Let's say again slash mkdir. Okay, and let's try to give name to say data. Okay, here guys, I will see that data came here. Okay, now see, now I have a PDF, right? Okay, let me first of all upload the PDF, and then I'll say upload the download. So I can't see. Okay, summary of mass. Yeah, I think we can do. Not I don't want the whole book. I can take is, let's suppose. Okay, case paper is there. Can't find this PDF, man. Sorry, guys, just a second, okay? Okay, got it. Sorry. It's fine. It's a bit difficult sometimes to just get the exact location of it. Now, see here. I'll just upload it here now. So like this, you can just come here, upload your data. So in now, I have stored it inside my production level. Yeah, here. Yes. Okay. So this, let's say a PDF I've stored. Okay. Now you see that now let's suppose the PDF has been uploaded. So it will just take, let's say, a few seconds to upload. It's been now done. You can see the PDF is here now. Now what I'll do here, guys. Now I want to read this particular PDF, right? So for reading that particular PDF, Llama Index provides you with something called as PDF reader. Okay. Llama Index provides you with something called as PDF reader. So from Llama Index dot readers, we need to import a PDF reader over here like this. From a llama index.readers.file, we have to import the PDF readers. You can see it's been installed now. Now, once I got the PDF readers, now see guys, okay. The when we discussed about it, it looked very difficult, right? Now you can see, okay, within a line of codes, we are able to, let's say, input every single thing that we have, right? You don't even have to worry much about it. So now what I'll do, guys, now very simple thing, let's say documents equals to, let's suppose documents, exactly. PDF reader dot load data, and from this load data, what I need to do now, I'll just copy this path from here, and I'll simply paste this particular path over here. And that's it, guys. So PDF reader dot load data, and from this particular PDF. So what I'm saying now, see from this Llama, what exactly Llama is saying? Hey, now whatever PDF you have, just give me that PDF. Let me load that PDF inside my own system, and I will see what to do with that now. See, as soon as I'll run it, so now it's been loaded. Now if I just print you the documents for you, see here, guys. See the complete data about the PDF is stored into one single line of code. See here, you can see all the documents. See, document ID is there. See here, and see page label is one. The complete data about page one. Similarly, page two, page three. Like this, you will have the complete data about it. Okay, like the whole data of this particular document is stored over here. So now till here, what we did now, we loaded the data. We got the data over here, right? Now once that is done, now what I need to do, I need to log in inside my Hugging Face API. I need to log in inside my Hugging Face API, right? Now see, now if I want to log in, then what I need to do, as I told you, simply run this particular piece of code. Now this particular from Hugging Face import login, get pass, import get pass, and here what you are doing, import the Hugging Face token. Now I need to run this, and I need to create the Hugging Face token out of it now. Now let's suppose if I run it, what I need to do, I simply need to pass whatever token you will get. Now let's say I have already created the token. So let me just copy it from there and I'll show it to you. Oh, I think I need to create again. Okay, just copy this token, right? So we can see this is how exactly it will look like, right? I will just now shown you, know. So like this it will look like. There's no problem for, I can definitely show it to you. When I create it, so like this you will see, you can just copy it from here. So once you now copy it, okay, once you now copy it, simply now paste it over here. Paste it over here. So means what? Neither you are sharing your secret key with anyone, or you are also keeping safe also. Simply enter and see everything. Now we'll see that it's running. Means what? Successfully you have logged in inside your Hugging Face. Means the connection of your this LLM or whatever this file is there is now with the Hugging Face API or Hugging Face. It's been, you are already connected with that. Now see guys, once now that is done, now what we'll do? Now we'll try to set up a simple prompt template for this particular, let's say for this particular system. Now again, what exactly this prompt template says? Again, it's very simple. The way we created the different prompts the other day for the OpenAI. Similarly, now llama index.core import the prompt template. So llama index automatically has its own inbuilt prompts where you just need to pass the simple thing. Automatically, it will just try to create the best prompts out of it. So what I did here now, system prompt. So you are a QA assistant. Your goal is to answer the questions which are accurately possible based on the instructions that are being provided to you. Okay, and this particular will wrap the default prompts inside the llama index. So when you see query wrapper prompt, so llama index will try to inside the prompt index like this. You have to pass, okay, user query, query string, and assistants. So just copy it and paste it. The same thing only. You can get it in official documentation also. So like this, now my prompt template is created. If I run it, see here guys, now my query prompt template is created. Now if I just print it, just to show you what it is, see here now. You have very custom prompt is there. You can literally create the perfect prompt out of it. So query prompt is created over here. Once the query prompt is created, now what I'll do guys, now finally I will try to load my LLM model, that is Mistral 7 AI, 7B. Okay. Now before loading that guys, one thing thing I'll tell you. Okay. First of all, we need to import something called as PyTorch, or you can just import torch. Okay, now see guys, now before let's say going in any details about anything, okay. So let me explain you what exactly the PyTorch is in simple terms. Because the complete LLM that you see, this complete LLM, ChatGPT, everything is written in PyTorch. So difference is like TensorFlow is there, Keras is there, PyTorch is there. So let's say whenever we try to ask the core questions about this particular field, right? So to the students also, like new freshers, entry people, we always try to ask the core differences between that. Because C9. Now let me first of all explain in very simple terms what exactly we are saying. Uh, just a second, guys. Yeah. Let me first of all. Okay, is my screen visible to everyone? Okay. Now see here, guys. Now, whenever I talk about this PyTorch or let's say TensorFlow or Keras, right? See, first of all, what basically the PyTorch is in simple terms, it is just like a PyTorch is a framework, or you can say open source machine learning library that was built by Facebook's AI team. They have built it. Okay. Now understand it, guys. The PyTorch is so popular. Okay, because of its, let's say, first of all, its dynamic support, the strong GPU system support. Second thing is lightweight. Means what? The complete LLMs that you see, right? You talk about ChatGPT, you talk about Anthropic AI, you talk about Mistral AI, you talk about any kind of large language model. Or see, all this ChatGPT, Mistral AI, what is that? That's called a large language model. It's a language model on large scale, large language model. Okay, so whatever LLM you see, right, large language model, every single thing is written in PyTorch. The best example was because they are lightweight in nature, very lightweight as compared to your TensorFlow or Keras. Okay, this particular thing is very lightweight. Okay, so now I don't want to go in details about it, but just simply try to understand it is built on top of PyTorch. Okay, so now because of that, what we did now here, we imported PyTorch first. Let me just get the PyTorch. Let's say now I have this torch imported. Now what I'll do now, the next part is I will create the Hugging Face API over here. So how will I do? LLM equal to, let's say now, torch, LLM. There's an object I've created equal to Hugging Face LLM that I have taken. So Hugging Face LLM. Now inside this, I will pass all the parameters which are required. See here. All these particular things I need to pass. Every single thing. Okay. So what I'll do now, whatever thing we have written, so we'll just take every single thing over here. Now I will explain in details, right? Now let me explain you what it is. See here, guys. Now here, see here, guys. So we got context window. What is max new tokens, right? I mean, see, in this particular Hugging Face LLM, okay, in this we have parameters called as context window, max new token, then generate cogs. In that we have temperature and all that we have seen yesterday. System prompt is there, query wrapper is there, and then tokenizer name is there. So every single thing is there, right? So what exactly it is, one by one I'll tell you. Yeah, stopping IDs also, like what the stopping IDs are, that also I'll tell you. But before that, now see here. Now, when I talk about this one, right? So what we did here now, we simply created the variable of this particular Hugging Face, this one. That's it. We create a variable out of it. Okay. So now understand here. First of all, what is this context window, guys? When I talk about the context window, means what? How much input is the model can remember at one particular time? How much input a model can remember at one particular time? Okay. So in simple terms, what? Let's say when you talk about GPT-3, right? So GPT-3 has the context of 4096 windows. This is means what? When you try to talk with GPT model, okay, so at one particular context, it can store 4093 context, means that much power it has. Okay, and at the same time now, GPT-4 is there, no, it can literally go to 128K. Understand the evaluation, right? 3.5, 4000 to 128K. So definitely that is, very, very important. So now when exactly it matters, guys, whenever you have the longer context, means what, let's suppose your text is very, very huge. Very, you need very long-term dependencies to understand these documents. Means suppose conversations are very, very big, so to understand these long conversations, we need to have this particular context size to be very, very big. Okay. Now, when I talk about this max new tokens, so what is that? So that is minimum number of tokens the model is allowed to generate in the output. So when the output will be generated at one particular time, how many tokens maximum it can generate in the output? So that's the size of it. Okay, 256 I can do. You can go from 100 also, no issues. But as depend, let's suppose if you are doing it for the practice purpose, and let's say it's a paid source, let's suppose it's a API, OpenAI API. So that time you can go for new token size to be less, right? So that you are just saving the cost of it. That's it. Okay. So it basically controls the length of the output, focusing on your cost only. Okay. So now all this generator cogs, like here, you know about temperature and all, right? So creative things, do sample is just like, imagine it's just like keep it false only. Okay. So like this, guys, now I have given every single thing over here. See here, I have now this query wrapper. So whatever query prompt I have written, see here, I have written a query prompt over here. Means inside this LLM now I'm passing the prompt directly inside only. Yesterday, what we did now, we explicitly written the prompt and then we send the prompt inside this. Now here, what we are doing, already we have got a, let's say function only, let's say, sorry, parameter only, where you are directly passing this as a prompt. And guys, now I need to exactly give the name of this particular tokenizer. See here, Mistral AI, Mistral 7B instruct V0.1. That is the tokenizer name that I'm using. So you might have seen this, right? Let's suppose. Now this is the one we are using, right? Let me show you now. So whatever the accurate name is there, so just simply take that particular name and write it here. See here now. Where is that? Okay, yeah, here. See here now. See, what is the model name now? It's exactly the same. Where it is? Yeah, see, Mistral 7B instruct V0.1. Okay, so that is the model that we are using over here. So whatever the exact name is there, just take that particular name and just paste it there. That's it. I mean, we don't have to do anything extra. Simply try to do those. And this is a model card name, Mistral 7B instruct 7B. Okay. So now what we did now, we just took the same exact thing that we have and we posted it over here. And that's the model name we have taken. And that's fine, guys. And tokenizer size is this much given. And guys, that is fine. Just run it now. Now see, guys, here you will see that now we are, what? The secret HF token does not execute automation with. No, it's fine. Okay, see here, guys, now. Now, understand, guys, one more thing I'll tell you here. See, here you can see that model size is literally 9.94 GB. Definitely, like, it's a Mistral model, right? Definitely, size will be very, very huge. See here, another model is there, 4.54 GB. Now you might understand, okay, like my laptop is definitely not that, powerful. My laptop cannot handle this particular part. So then how am I supposed to do this? Very normal question, right? But guys, understand the scenario over here. So this is where, Python has the best. So when we say, okay, Python is like the, sorry guys, just a second. Yeah, sorry guys. Okay, now we were just into this, right? Now see, you can see here, guys. Now see here. Look at this particular model sizes, right? Let's say 9.9 GB, 4.54 GB. So you might ask, okay, my model, my system itself is do not have this huge power. So how can I do that? So guys, this is where the core Python comes into play. So in the Python, there is a concept called as quantization. Okay, it is called as a quantization. Means what? Though the model size is this particular huge. Yeah, okay. So though the model size is this particular huge, but still we have that particular ability where automatically this Python will try to reduce this particular model into a smaller sizes. Okay, means what? Let's suppose if 9.9 GB model is there, so automatically it will be shrinked to let's say 1 or 2 GB only. Okay, 1 or 2 GB only. So this quantization, it's called as bitwise quantization. It's called QLoRa or something. Those kind of techniques are there, which are a bit popular technique to reduce the techniques. Okay, which are inbuilt now. So there now you don't need to worry about. Okay, so don't worry ki 9.9 GB is not loaded inside your own system. Okay, it is in this environment itself. It is not in our own system. Okay, so this is where we called as quantization techniques, and we also call as sharding. Sharding. Okay, the shards that you can see, right, might have been downloaded somewhere. Might be, I'm not sure, but yeah, should be there somewhere. It will be there. Okay, so the shards are the ones who are more responsible to reduce this particular size. Okay, so and see, as I told you, right, it's built in PyTorch. So PyTorch also has like inbuilt bit sizes. So with respect to that bit size only, it will just try to take only that much amount of data which is actually required, or whatever size is required, that will only automatically it will take. Okay, guys. So now till here, now my LLM is now completely system. Means everything is done. Now I took my data also. I passed my PDF also. I converted that PDF into the numeric form also. Embedding also done. And now I have loaded my LLM also. Means what? Now every single thing, almost every single thing that is required is now done. Now what I need to do? I simply need to, let's say, first of all, now I need to get the responses out of it. So before getting the responses, I'll just need to install this instructor. It will be there. Yeah, it's already there. Okay, sorry. Okay, now from here, now I just need to get the response of this particular model. So now see here, first of all, we got this particular vector store. Vectorization is done for the vector files data that we have used. I told you, right? Llama index was providing. Now what I need to do, I need to convert this particular data into the embeddings, right? Llama index also provides with the Hugging Face embeddings. So now to convert the data into the from textual data to a numeric form, what we are using now? Hugging Face embeddings. So as I told you, right, okay, in classical NLP, we use TF-IDF, Word2Vec, all those embeddings are there, right? OpenAI provides with OpenAI embeddings, like ChatGPT is there. Okay, so Llama index also provides you with the Hugging Face embeddings. And what kind of embeddings I'm using now? Sentence transformers, all MPNet based V2. So this is the model that I'm using to convert my textual data into the embedding format, or that is a numeric format. And here what we did now, here now we have successfully created our database also. So here vector store index, that database is set already now. Now I only need to convert this into this embedding format. Now, as soon as I did this now, let's try to run it. Module name llama index and okay, I think I need to install this. Yes, yes, yes. Specifically install it, no? I did not install it, sorry. So here you don't have inbuilt things, right? So here explicitly you need to install everything. Okay. So llama index again faces being installed. So it's been installed. Okay. Now if I run it, I can see that now see here. Now again this model is running. And finally now my whole data that I have is now converted into the vector form. Means what? I have got my data over here. Means embedding technique I have got. Now what I'll do simply, now very simple thing. What I'll do now, I will try to store this complete data over here. Right. So let me just take it. So here now I'm getting this core vector index that I have created. And now settings.llm. So it's just like a model. In the Llama, there is a model called as settings. So now we are taking whatever LLM that we have used. Okay. We are taking whatever model that we have used. What model we have taken now? That Mr. AI model we have taken. And what is the chunk size that we have? Now I told you, right? Let's say this one now. This chunk size. Now here we are defining the chunk size over here. Look at this one. Okay. Where is my this one? So here we have defined the chunk size right here. This chunk size, text chunk. So we need to decide, okay, how many chunks should be there in one single data, or let's say one single thing. So we are taking 1024 chunks in one single process. Okay. And finally, now we are creating the indexes over here. So what we are doing now, one simple line of code, vector indexes dot from documents. So from documents means what? We have created these documents over here, right? So from documents, create means in simple terms, what we are saying, okay, create the vector index from this particular documents in simple terms. And that's it, guys. See here, I will just take some time and now it is done. Okay. Okay. Now, if we just see the indexes now, see now we have created this complete indexes at this particular object. It's been stored. Okay, guys. Now, I know you can't access like this. It's not successful. Okay. Now, see here. Now, finally, I'm just adding this logging over here so that it just imagine uh, while getting the answers now you will see that you will get a lot of extra things over here. So just to avoid that extra things, we are just removing this, taking this logging over here. So explicitly we have written logging files, right? That is it. And finally now, guide, I will create my query index. Now this is like my query engine. So now index as a query engine and just run it now. And finally, guys, this is done now. Now simply ask the question. Let's suppose now I will ask, okay, response equals to, simply let's say response. I want to response equals to, let's suppose now query engine. And let's suppose now in the query engine, what I'll ask, let's say, let's pass a query, dot query. Okay, and let's start, okay, how the attention or let's say how the generative AI works. Okay, simple question, right? And guys, that's the simple thing. And finally, what I'll do now, I'll simply try to just print the response. Means here we are just trying to print the core response. Okay, print the core response. And if I run it now, guys, see here now. Now its model is running. Now from this particular PDF, now it will just do the all process that I told you. And from here now you will get the index, a reply over here. Okay, you will get only response now. You will not get any unnecessary things. Response will only give you the proper response that is available in that particular model. Okay. So guys, in this particular way, you try to talk with your PDFs, right? You try to talk with your PDFs. Means very easily. Now this is just one example I took. Now I'll show you one more example now. Wait. So yeah, it takes time here. I mean, open source model is there. The code is not optimized properly. It just like to show how to get the results that we are doing here. So it will take time. Yes, yeah. See, generative AI is a type of intelligence that is capable of producing content in various formats such as text, audio, pictures, and everything. Means whatever thing is written inside this PDF, that is the only thing it is answering. Now, if I ask, okay, let's say who is who is the Prime Minister of India? Yeah, see here. Sorry, I'm sorry, but I do not have access to that information. Can you please provide me the more context or the different question? Why it said that? Because now guys see, now we are limited to only this particular PDF. What I told, okay, I want to talk with my PDF only. Now, I don't want you to act like a LLM or give me any different type of response. No, I don't want that. Okay. So whatever things you have the, it's in this particular thing. Let's say now, okay, can you summarize the this whole PDF in the simplest words by understanding four topics covered. A simple example. Okay. So now it will just try to get it and it will only get the responses which are actually present in that PDF. Okay, guys. So this is how exactly, we build this simple type of applications. Now in this, let's say it was very easy. Now, eventually, let's suppose now instead of this llama index, you can use LangChain. Process will not change, only instead of llama index, write LangChain. Wherever you are using, let's say this particular thing, if you want to use OpenAI, use OpenAI. Yes, simple implementation will change a little bit, but the idea is same. Whether you use this one or whether you use that one, that idea will not change. Okay, the idea will not change. Okay, so to guys, everyone, is this particular thing, everything is clear today? Like, did you all understood? See here, now you will get the complete summary of this particular PDF. Complete summary of this PDF in very, very simple terms. Okay. So everyone, guys, is it clear to all? Like, did you all understood how this particular thing works in very simple terms? How easily you can create your own things? Okay, now we have like 15-20 minutes. So I'm open to your doubts. So I request everyone, whatever doubts you have, please let me know because I think this is the last day, right, today. And so if you have any kind of doubts, please, I would love to hear from your side. Like, I hope the whole 5 days were, very perfect for you. You might have learned a lot of different things. You might have learned very new techniques, how to use them. Along with the chat GPT, there are like many different models you might have learned about. Okay, it's not only chat GPT, it's like multiple things that we can actually build, around the same particular part. Okay. So guys, was it helpful to everyone? Thank you. Can you share the files after the session? I think you have my GitHub, right? From there only you can just take it. Or the files. I think till yesterday all the files are shared. I'll share this one also. Okay. I don't have an ability to. I can't upload anything here. I think so that is not possible. So can I get your LinkedIn? Sure, sure. No, no. See, the model you're not loading the model in your own system. It's not a local system you are storing. It's like cloud thing. This Google Colab is a cloud thing now. Let's suppose if you just disconnect this no, and now it will nothing will work. Now it's everything is gone. Now again you need to run everything from the first line only. Okay, so it's like completely an open source. I mean, it's like an cloud based thing. So you don't have to worry about all these things. Okay. Sure, sure. Yes, thank you so much. Thank you. It was great. Yeah, sir. Sure, sure. Just take this one. Okay. Yesterday's files are shared. It was one project that we did. It's shared in the GitHub. I'll try to upload the same, this one also over there. Okay. We'll get it from there. So guys, everything is clear? Yes. Yeah, today. No, no. Okay, fine. Have any doubts? Please let me know.
Yeah, dear faculty members, I know you all have a doubts related to certificate. I'm surely going to answer this question. Before that, we still do have like 15 minutes. So please ask the questions for the trainer. If you have wanted to know any related to subject, please ask the question so that he can answer. Related to certificate, I will answer it later.
Sorry, future enhancements or research in GenAI, sir. Like, can you be more specific about it? I mean, whether you're asking what kind of research is going on or what kind of enhancements are coming, or you are working on something related to that, you want to ask like more, a little bit specific? See, as far as current enhancements are going on, right? So currently now world is more moving towards the part of agentic AI. Okay, where now we are building different agents to do a certain task. Let's suppose now we build this whole system, right? So now what will have is, let's say there will be one agent who will be extracting the data. There will be one agent who will be, orchestrating the data. There will be one agent who will be cleaning this data. So there will be one agent who will be, means what, like let's say every single agent will be doing one kind of task. Okay, now that is like the, where we are now currently moving. Now this is like, more of a too much of advancements. And into that particular part now currently again after agentic also now we have something called as MCP servers. So this MCP is now again like, some kind of imagine this as, let's say just something like the similar what we have been looking till now. Okay. So now there are like a lot of things which are, happening in this domain. Okay. So this is the current thing and current research that's going on in Gen AI. In future, as I told you yesterday also, right? So like future actually holds very wonderful for those who are, as I said, as a AI engineer. So if you really want to pursue a career, right? So that can be like a very good option, in future, because there we'll also talk about very core statistical things, building this kind of models and also using this kind of models. So both the things go hand in hand. So yes, I think that is really some, good advancement that we can think about. Yeah, yeah, sure, sure. See, why DeepSeek is too popular? The only thing was, let's say, the way DeepSeek was created. It was like very, very unique. There is no such kind of difference, but it's just like, when you ask a question to a DeepSeek, so it will say, okay, now we are okay, the user is asking certain kind of thing. Now we are thinking about this particular problem. Now we are trying to, let's say, build some kind of, so they just try to create a, we just call it as a very good environment around that question, that's it, that itself. Means very easily they will try to write that particular question in a way, like you will just feel, okay, there is some kind of unique thing that's happening over there. Right. So, okay, you will, when you search in a deep seek, you might have seen, right? Okay, first of all, it's okay. Now it's thinking, user is thinking. The user is asking this particular thing. Now I need to think in this particular way so that user will get the best possible reason and answer. So therefore, DeepSeek was very unique. And the biggest advancement and the biggest change that actually happened into the DeepSeek was the costing. Okay. It was literally 10 times less costly, costlier than what other LLMs are built, and it was like 10 times more effective than what exactly it is now. Not 10 times, but it was much more better and effective than what other LLMs are. Right now, again, it's not like too much of thing also, like, it's not, won't say it's like very, very better. Okay, yeah, in some kind of parts, like, maybe some kind of generation tasks, okay, it can, be better. But I mean, it's almost same only. It's not like too much of difference. But the only thing was that, because of his reasoning capabilities. Okay, because of its reasoning capabilities, DeepSeek actually got so much of famous. Let's say, if I now talk about, let's say, why, let's say, core difference between why exactly DeepSeek was so famous and loved by people, I know, and what difference actually it has with respect to the other LLMs. So see, the core difference is nothing. The idea is same only. Okay, but the only thing was, the one thing was about the cost effectiveness. It was very, very effective. Means they literally have other LLMs have literally spent $10 billion. So they literally created this into $1 billion. Like that was the thing. Okay. So in simple terms, it's just like China, right? So they always come up with something that is very, very unique. Okay. And the biggest part was that, as I told you, there you don't have like too much of restrictions. Okay. Now it's a very easily it will tell you, okay, this is how its architecture looks like, this is how the problem is, and this is how exactly you should approach that particular problem. Okay. So in other things, if I talk about performance and efficiency, okay. So like any other model, no, the performance was much more better. That's definitely there. Okay. And another thing was like multi-language. Like multi-language support was like another thing. It was very much competitive to English also. Okay. Now, as I told you, let's say, simple tokens had, let's say, GPT-4. Okay. So, in the GPT-4, now if you just see, the token size was not that high. We cannot handle so many tokens at once. But DeepSeek came up with that also. It had like some plus advancements into the token size also. Okay. Now, and second thing was, when you talk about codes, reasonings, okay, in such kind of task, DeepSeek was much more better. That's for sure. Okay. Because it is very extensively fine-tuned with math problems. Okay. Then logical reasonings. So all these things, it is very extensively fine-tuned with that. Okay. So because of that, these are the simple ways because of which that was pretty famous. Cost was the one part. I mean, the amount of cost that they use, that was so less. And with such low amount of cost, they were able to build such a nice model. So that was the reason, it was so famous. They always come up with something unique, right? They are 50 years ahead of us, that's for sure. I mean, the kind of advancements that they have, they're like immense. Okay. They were talking about all these LLMs and all like 15 years back, 10 years back. Yeah, these reasoning models are great. That's true. Yes, yes. Anyone, anything else? Thank you. Thank you, Bully. Sure, sure. Uh, we are trying to build something. How can you? What kind of guidance you are expecting? I mean, when you say, can you guide us through that? Hmm, okay. Sure, sure. Let's, we can definitely, connect on it. No issues. Apart from that, anything else, please let me know. Or else then, thank you so much, guys. It was wonderful talking with you all for, 5 days. Thank you for so much a great cooperation from you all. And yeah, I think I'll see you all soon. Maybe in some, other sessions or, maybe some other learnings. Okay. Thank you so much, everyone. Bye bye. Take care. Thank you all.
Yeah. Yeah, thank you so much for your wonderful session of all these 5 days. I hope this has been helpful to our faculties. We'll look it forward for the next FDPs or STPs. We'll meet there. Thank you so much.
Sure.
Yeah. So, dear faculty members, I know you all have so many questions to be asked related to certificate. So, as you all already attended few of the faculty development program in XLR, as you all know how the process work, we already informed in the session, the day first. As you have to secure above 60% of attendance, then only you will receive the certificate. Okay. So this is one of the important point. If you secured 60 or above 60% of attendance, then only you will receive the certificates. Okay. So the certificate we will be sharing to your register mail ID. So whichever the mail ID you have been registered in XLR will be sharing to the mail ID. And with we at least require 10 to 15 working days to share the certificate. Okay. Please be waited if you all mark the attendance or if you secured above 60% of attendance, for surely you will get a certificate. Please be waited for at least for 10 to 15 days. Okay. Yeah, any other questions to be asked? And like some are asking for previous day's attendance. Sorry, we are not able to share that previous day's attendance link. As you already know, the attendance link will be active for 1 hour. That will be for 4:30 to 5:30. So the previous one attendance link will not work. So we are not able to share that. Today's attendance link I have just shared in a chat. If you have missed out to mark your attendance, kindly mark your attendance. And materials, whatever the like PPT or the materials has been used in the session, that I'm going to be upload in the LMS dashboard. You can leave over there. Any other questions to be asked? I will wait for 2 more minutes. Is there any questions to be asked? You can ask me out so that I can answer. Veera said there is no any test. So in FDP, like for in faculty development program, we will not conduct any test or assessment. Okay. I hope you all don't have any questions to be asked. I see there are no questions to be answered. Okay. Yeah, thank you all. Thank you for joining all these 5 days. Thank you so much. We'll meet again on like for upcoming FTPs or STPs. Okay. Yeah, thank you all. Have a great day.